Hi, everyone. I hope everyone's doing as well as they can be under the circumstances. So, here's a quick review of some of the notes that we've gone over for Intro to Chemistry so far for the upcoming quiz. Now, I'm going to go over some of the more major topics, things that we will focus in on a little bit more on the quiz, but I do want you to make sure that you do review all the notes that we've gone over so far, the problems, and the Khan Academy assignments. But a little more focus on using the periodic table, definitions of key terms, calculating the average atomic mass, and determining the number of atoms in a given mass of a substance. So, as far as the periodic table is concerned, you should be able to use that to find the number of protons, number of electrons, and the number of neutrons that an element has. So those are all things that you should be able to do pretty easily when you look at the periodic table. There's a lot of other things that we will end up using the periodic table for down the road, but for now, that's what you need to focus on. At some point as we progress, we'll probably spend a week or a little bit more just on the periodic table. Now, as far as definitions are concerned, there are a lot of different key terms, but things that you should definitely know: isotopes, ion, mole, atomic mass, so on. Okay, so just kind of review some of the different key terms and definitions that we've gone over so far in the notes. Calculating the average atomic mass. Just a few things. There has been some confusion with this. So just to kind of just go over a couple of things. This is also known as atomic weight. Those terms are sort of interchangeable. It's just another one of those kinds of confusing things that you run into in science and chemistry. But average atomic mass and atomic weight are basically the same thing. Okay. The other thing that we want to focus on, the last thing here, is determining the number of atoms in a given mass of a substance. So basically, you'll be given the mass of a substance in grams. You need to be able to find how many moles that is, and then take that value and change it into atoms, and then be able to go the other way. Right? If I gave you the number of atoms of something, you should be able to determine the number of moles, and then one more step, figure out what the original mass in grams of that substance was. All right, I want to start with calculating the average atomic mass. So the standard equation that we can use or apply for this would be mass 1, percentage 1 plus mass 2, percentage 2 plus mass 3, percentage 3, and so on. The subscripts here, 1, 2, and 3, indicate the number of isotopes that we're dealing with for that element. Now, those are the isotopes that occur in nature. So some elements may only have 2 isotopes, some might have 6, and so on. The percentages, the P1s, P2, P3, that's the percent natural abundance. So on the planet Earth, how much of this particular isotope do we have compared to the other isotopes? What percentage does it represent? Now, don't forget isotopes. What these are, they're atoms of an element with the same number of protons, but a different number of neutrons. Because they have a different number of neutrons, they have a different mass. Okay? Because they have the same number of protons, it's the same element. Right? The number of protons determines the atomic number, which determines the element that you're dealing with. Right? So that gives you the element, but then a different number of neutrons determines what isotope it is. Now, for doing the calculation, the example that we're going to use is oxygen. So on this planet, we have 3 isotopes of oxygen. O16, which is 99.759% natural abundance. O17, which is 0.037% natural abundance. And then O18, which is 0.204% abundance. So we're going to do the calculation out. The mass for O16 is 15.995 atomic mass units, or U. And when we take the percent, we have to write it in decimal form. So make sure that you move the decimal 2 to the left. All right, so 99.759% is actually 0.99759. Add that to the mass of O17, which is 16.995, times, change that to decimal, so that would be 0.00037. And then the last one has a mass of 17.999, times this as a decimal, 0.00204. You do the math out, and this is the answer that you would get in your calculator, 15.999. We will round to 2 decimal places, so this will end up being 16.00. Okay, when we round this up, it gets to 16.00. Don't forget to write those zeros. Those are significant. So this would be oxygen's average atomic mass, or you could say its atomic weight. Just to point out, there are some periodic tables that may write it out a little further, like 15.999, but the periodic table that we're going to be using, 2 decimal places. On a test or quiz, you would have this information, right? I would have to give you these masses and the percent abundances. You would just have to be able to carry out this calculation. Okay. As far as the periodic table and things you should know and be able to use and do, when we see the element in its element box, this is the kind of information you're going to get. Right here is the atomic number, which also means the number of protons that the element has. So oxygen has 8 protons. There's the element symbol, and then here's the element name. At the bottom is the average atomic mass, and like I said before, that can also be the atomic weight. This number up here, depending on the type of periodic table you're using, it may have the oxidation number, which is a number followed by a positive or a negative. All right, that's to talk about the number of electrons that that particular element has. Some tables will have something different here. It'll have the electrons and in the orbitals that they're in. But this table that we're referring to right now is talking about the oxidation numbers. One last thing to kind of point out here that's not written, this 16, the other units that you can have for this would be grams per mole. So this would actually be 16.00 grams of oxygen per mole of oxygen, right? And that'll be useful later when we're dealing with Avogadro's number and figuring out atoms. All right. Back to how to use the periodic table. So to find the number of neutrons, what we do is we take the atomic mass and subtract the atomic number. So in this case, the atomic mass is 16. The atomic number is 8. So 16 minus 8 gives us 8. That tells us that oxygen has 8 neutrons in it. All right. Over here, to figure out the number of electrons, what we're going to do is we're going to take the oxidation number and subtract the number of protons from it. Now, when we do this number, the way that we have to write it on the periodic table or when we're writing out the ions and isotopes for the element, we write the number, then the positive or negative. But when we go to figure out the number of electrons, we want to take the sign and put it in front of the number, just like a normal mathematical operation. So oxidation number minus number of protons will tell us the number of electrons. So in this case, we have a -2 for the oxidation number minus 8. So when we do that out, we get -10. So we have 10 electrons. Now, if you think about it the other way, like kind of like some of the problems we've been doing, if you take -10 and add 8 to it, you end up with a -2 or 2 negative. So this atom right here has 2 extra electrons. It's not balanced with the number of protons. Okay, using Avogadro's number. So just to kind of refocus on what this number is, Avogadro's number is 6.022 times 10 to the 23rd. And that's referring to the number of atoms or molecules in a substance. So every substance has this many atoms in it. But really, like one of the videos on Khan Academy, it's just like saying 12 is a dozen. So you can have 6.022 times 10 to the 23rd. That's Avogadro's number. We can say we have a mole is Avogadro's number, or 1 mole of an element is 6.022 times 10 to the 23rd atoms of the element. Okay, so 1 mole is this many atoms of that element. This right here is really what you should focus on, right? The conversion. 1 mole equals 6.022 times 10 to the 23rd atoms. That's for any substance or element that we're dealing with. Other ways that we can write this, and this will be important for doing conversions, is we can write it as 1 mole over 6.022 times 10 to the 23rd atoms, or we could write it as 6.022 times 10 to the 23rd atoms per mole. So just make sure that when you see this, you know that you can write it this way or that way. The best way to understand how to use Avogadro's number is to do a calculation with it. So the example that we're going to do is, what if the question was, how many atoms of gold would you have in 58.27 grams of gold? So when we look at the periodic table, we know that gold is Au. It has an average atomic mass or weight of 196.967 U, or atomic mass units. Right? So what this means is that we have 196.967 grams of gold per mole of gold. Right? That's really what it means. Right? From the periodic table. So 2 steps. First, you want to change the grams to moles. So 58.27 grams of gold times, and we're going to use the conversion factor of 1 mole of gold over 196.967 grams of gold. So the grams of gold cancel. You end up with moles of gold. You're going to have some answer over here. I didn't put it in. You'll see why in a minute. The next step would be to convert moles to atoms. So you take this answer and multiply it by 6.022 times 10 to the 23rd atoms of gold per mole. You get an answer. Or you could just do it all in one step. Grams of gold times mole of gold over grams. The grams cancel. Times 6.022 times 10 to the 23rd atoms of gold per moles of gold. So now the moles cancel. And in one clean step, instead of having to do 2 steps separately and write the answers out, in one step, you go from grams to atoms. This would be your answer. 1.782 times 10 to the 23rd atoms of gold in 58.72 grams of gold.